Hey guys, what's up? So today we're going to be looking at finite and infinite sets, and it says a finite set and it says in a finite set it is possible to count and name all the elements in the set. And it says an infinite set it is not possible to count and name all the elements in the set. So let's look at this example now. Let's say you have three dogs, right? One is a German Shepherd, one is a poodle, and one is a mongrel. Okay, right? And you can name all the three dogs, right? And the number of dogs is 3. The number of elements in A is 3. Hence, the set is finite because you can name and count the 3 types of dogs, right? Now, let's look at this second set here. It says let R be equal to X such that X is greater than 0 and X is an element of the real number set. Then the numbers of elements in R are actually infinite, right? Because it's from 0 to 1, 2, 3, all the way to infinity. Like it keeps on going on forever and ever, right? So this is an example of an infinite set, okay, guys? And we have some notes here that says also X such that this notation here, where it says X colon, this colon means such that dot 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 means the set of all X such that, and it is a part of set builder notation. Okay, so please write this down, guys, because you're gonna need to know this. You're gonna use this often. You're gonna use this terminology often, where you have X colon, where the colon means such that. So this is saying X, the set of all X such that X is greater than 0 or X is whatever it is, and so on. You're going to use this really often, and it's basically called set builder notation. So try to get used to it, and we're going to do some examples now to make this easier for us. Okay, guys? All right, so let's move on to the null or empty set. All right, guys, so we're looking at the null set or the empty set now. And it says the null or empty set contains no elements and is denoted by the symbols open brackets or a O with a cross through it, right? Just like this here, same one. And it says if A is equal to human beings which are able to see through walls, right? Like some superhero type guy. A is equal to the empty set because no human being can see through a wall, or it's equal to the same notation here, O with a cross through it, right? That's what this is. And A is an empty set. All right, guys. Cool. So we know what finite sets are. You can count the number of elements in that set, like 1, 2, and 3. We know what the empty set is, right? Which is this one. Nothing is in the set, or a 0 with a cross through it. And we know a finite set. We know an infinite set, right? So for example, X is such that X is greater than 0, right? And where X is an element of the natural number set, this is an infinite set because it goes on forever, okay? You can't stop counting it, all right? Okay, so let's do some examples now, guys. All right, guys, so let's look at these 3 examples now. And it says determine if the following are finite, infinite, or null, right? So the first one here says B is equal to a set such that where X, all the members in the set, are such that X is greater than 4 and X is an element of the real number set, right? So if X is greater than 4, the set would be everything greater than 4, right? Which would be 5, 6, 7, 8, 9, 10, 11, all the way to infinity, right? So clearly this one is infinite, okay? Because it goes on forever. Now the second set here says C is equal to the people who have been to the planet Jupiter. And I'm sure no human being has been to Jupiter. So this is the null set, okay? This is the empty set, all right? Okay, and the last one here, guys, says that x is greater than or equal to 1, but less than or equal to 3, right? And x is an element of the natural number set, okay? So what this is saying is that x is either equal to 1, which would be 1, which is in the natural number set, 2, which is between it, and 3. So it's basically between 1, 2, and 3. And there are 3 numbers in that set, right? So n of n is equal to 3. And it's finite, okay? Because we're able to count the number of elements in the set and list them exactly, okay? So this one is actually finite, okay? Awesome, guys. Okay, so let's just move on. All right, let's look at the universal set now. All right, guys, so that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.